Hello guys, welcome to today's video. Um, we will be continuing for where I stopped last time. I stopped at half and double like well, I started off with double angle identities. Before that, I did supplementary angle identities, and before that, I did some examples. I think two examples. Okay, so today we will be analyzing, well, not analyzing, we'll be deriving the half and double angle identities, the formulas for all of them, and we'll do some derivations in projectile motion, and that will be all for today's video. So, what are the requisites for what you need to understand half and double angle identities? The requisites to understand these things are the sum and differences of two angles. I'm only doing for two angles. I can't do for three angles now. Or you can do for more. The thing is, for any n angles, you can always separate n angles into n minus one and n angles and one angle, something like that. So you can have, let's say you have n angles. Okay, yeah. So if you have, let's say x, sine of x, where x is greater than 2, you can say where x is greater than 2, you can, well, what I mean by 2 great, not the value of x to be greater than 2, where the variables that x is denoted as are greater than 2. So you have, let's say, x equal to 1, 2, 3, 4, right? So that's what I'm trying to say. You can always separate it into two angles anyways. You can say sine x is equal to sine of the first angle plus these other angles, so 2 plus 3. So you can always generalize angles, any n angles, into two angles for the sake of simplification. But that's not what we're focusing on today. What we're focusing on today is so the requisites to understand half and double angle identities. So you need to know what sum and difference of like two angles is. And well, I'm going to do it very quickly. So I have cosine a plus b equal to, I'll just do plus or minus sine twice is equal to hopefully you understand that. And sine a plus b is equal to, well, for tan I'll have to do it again because, well, I did two videos for tan. The first time when I was doing for tan, I made a minor error, and I'll just do the derivation again so you can see what's happening. So this is sine a plus b, sine a cos b plus sine b plus or minus sine b cos a. Right, so plus or minus for tan. Now let's do tan explicit b. Tan a plus b is equal to sine a plus b divided by cosine a plus b. And this is equal to sine a cos b plus sine b divided by cos A cos B minus sin A sin B. If we divide all through by cos A cos B, we have we know that here is surely going to be 1. So if we divide by cos A cos B, here, that'll be 1 times tan A, right? Because sin A over cosine A, that's tan A, and cos B divided by cos B, that's 1. So 1 times tan A equal tan A. For this, you have minus cos A divided by cos B, that's 1 times sin B divided by cos B, so that'll be tan B. Minus, is it minus? Yeah, well, this is plus here. This is minus here. So sin A divided by cos A, that's tan A. And sin B divided by that's tan B. The other time I forgot to divide by cos B, so I just wrote tan A there, which is wrong. And that's for plus. Hence, tan A minus B is equal to tan A minus, change all the places where you see plus to minuses and all the minuses to plus. So tan A minus tan B. 1 plus tan A tan B. Okay, so this is the requisite for you to know how to do half and double angle identities. Without wasting much of your time, let me see my camera resolution first. Okay, it's just fine. Without wasting much time, just going to draw a box here. Okay, now let's get to the main meat of today's work. If we had A, I'm trying to think of how to do it so I can also include for double angles. Okay, if A is equal to 2A, right? You know what, let's do it this way. Let's use actual angles. If A is equal to, if the, how do I say this? Okay, if A is equal to 2 times an angle theta, therefore cosine A is equal to cosine 2 theta. Okay, cosine 2 theta is equal to cos this plus this, right? And we know this is equal to I think I should write it bigger, so cosine that plus that is equal to cos theta minus sin theta sin theta. Multiply that, so you have cos theta squared, but I don't like writing trigonometric functions like that, so I just write cosine squared theta minus sin squared theta equal to, hence cosine 2 theta is equal to cosine squared theta minus. So what I'm actually doing here is the double angle identity, but let's go further. Sine squared theta. But we know something. We know that sine squared theta plus cosine squared theta is equal to 1. Hence, if we solve for sine squared theta is equal to 1 minus cosine squared theta. Right, so cos of a double angle is equal to cos squared theta minus, well, plus cos squared theta minus 1, and that's equal to 2 cos squared theta minus 1. If we solve for cos theta, I hope you can see what we're doing here. If we solve for cos theta, we see that, well, let's do it slowly. So 2 cos squared theta is equal to cos 2 theta, oh, not a, 2 of angle theta plus 1, well, divided by 2, right? Hence cos theta, or therefore cos theta, you can see is equal to the square root of cos 2 theta plus 1 divided by 2. You can see how we had the first okay, you can see how we had the first angle, which was actually a double angle, but written as a single angle, and we wrote that as 2 times another angle, right? So, and we found that that angle is equal to the square root of cos A, or cos 2 theta plus 1 divided by 2. You can actually write this as a half angle identity, but we're not there yet. Okay, so we derived for cos theta from here. If you also solve for cos squared theta here, we see that cos if we put that into the equation here, we see that cos 2 theta is equal to 1 minus 2 sine squared theta. So cos 2 theta plus 2 sine squared theta is equal to 1. You could actually bring out a question from here. You can say, prove that, show that, but we're not going to do it, that cos 2 theta plus 2 sine squared theta is equal to sine squared theta plus cos squared theta. Because they're both equal to 1. But that's not what we're trying to focus on today. Oops. Okay, so let's solve it. So sine squared theta is equal to 1 minus cos 2 theta divided by 2. Therefore, sine theta is equal to pretty straightforward, yeah? It's pretty straightforward. It's not too difficult to derive. I mean, you can do a whole slew of problems from here. You can say, given that the angle theta is equal to 1 divided by root 3, if cos theta is that, phi sin theta, so you can just rewrite the question. You know, you can solve a whole slew of problems here. Hopefully I'll get questions to solve. But that's not what we're doing today. Today we're just deriving and we derive and show you and explain how the derivation comes forth. Yeah, so this is the angle for, this is a half angle actually. So we say that the half angle is equal to 1 minus cosine of the full angle divided by 2. And so on and so on. You can derive a whole lot. So there's nothing really, you can, if you really want to see the half angle in this, let's say, it's not too hard really. Let's say this was an x, and you say x equal to half of x plus half of x. You see that sine of x divided by 2 is equal to 1 minus sine x divided by, just write, I think 1 minus sine half of x, or sine x over 2 is equal to 1 minus sine, 1 minus square root of 1 minus cosine x divided by 2. It's really the same thing, half and double. It's just, this is more explicit than doing double angle identity. So if I have x is equal to half of x plus half of x, you'll see that cos of x divided by 2 is equal to cos x plus 1 divided by 2, and sine of x divided by 2 is equal to 1 minus cos x divided by 2. Right? So yeah, it's really the same thing, but one is just written more generally than the other. I'm trying to really not waste time on this video. So this is for, I hope you can see the half angle identity in it. Well, the double angle is quite obvious because we're actually using full angles instead of using fractions. Well, here you can see that this is like a fraction. X is like a, and theta plus theta is like half of x with half of x. So we're not using fractions here. You can use fractions if you wanted to, but this is a more general form up to here. Let's do for tan. Perhaps I should leave this on the board for a bit, but it's quite obvious. So